Hi everyone, it's Dexter from A2K, and thanks for joining us for today's webinar, Fusion 360 Freeform and Surface Modeling. Applications engineer John Pitcher will be presenting for us today. So before we start, we'll just go through about A2K. We're all about fostering innovation through consulting and training. A2K Technologies plays a vital role in helping infrastructure, building, mining, construction, architecture, and manufacturing industries reach their full potential by delivering technology solutions and support services such as education and consulting. We work with visionaries to shape the future of design and in turn enable them through innovation to minimize risks, improve productivities and achieve excellence. A2K Technologies is considered the business partner of choice and trusted advisor by vendors and clients. We partner with major software and hardware vendors to meet clients' technology needs. We strive to exceed client expectations by pinpointing their challenges and delivering solutions through experience and innovation. We work with clients and companies of any size nationally and abroad. Over to you, John.
Thanks, Dexter, and I'd like to reiterate Dexter's welcome. Thanks for joining us today, everyone, and it's great to have you along for today's webinar, where we're going to discuss one of Autodesk's key CAD applications, Fusion 360. So this is part 4 in a series of 4 or 5 webinars. Sorry, we've got one more to do. Sorry, 4 in a 5-part webinar that we'll be doing on the Fusion topic, and we may expand this out if it's of interest to people to cover other topics as well. But we have one more subject to cover in this particular group, and that'll be around the concept of drawings in Fusion 360. So just a couple of things about myself. First up, as Dexter mentioned, my name's John Pitcher. I'm a certified Autodesk trainer and technical support engineer. I did my time as a fitter and machinist many years ago and spent quite a bit of time in the CAM space. So my background is in CNC manufacturing, and I've worked in a number of different aspects of manufacturing, hydraulics and pneumatics, machine tool design and manufacture, and a number of other aspects as well. I worked for a period in the wine industry, working with designing products for wineries, etc. So for the past 13 years, though, I've been connected to the Autodesk line of products and training products like Inventor and Fusion, AutoCAD, and a range of the Autodesk line of mechanical engineering products. But for the last couple of years as well, I've also done some work in the additive manufacturing space, or what we commonly call 3D printing side of things. So that's just a little bit about me. So yeah, as I said, today we're going to be talking about some aspects of Fusion 360. Fusion 360 is a very interesting product. Just a little bit of background on the product first up. It's a very powerful CAD application, or CAD-CAM application. It's a relatively new player in the sense that it was developed in the late 1990s and through to the 2000s. And really that gave it quite a competitive edge over many other CAD packages, because the developers of Fusion 360 were able to leverage things like high-speed internet, cloud storage, and cloud processing to make Fusion a very powerful and collaborative engineering tool that offers designers the edge over many other CAD systems that are available today. So as I mentioned, Fusion 360 has a very powerful CAD interface, but also a CAM interface and numerous other CAE type tools for computer-aided engineering, whether it be simulation, rendering, a whole bunch of other tools that enable us to work with Fusion's very powerful interface. Obviously, as you'd all be aware, current trends and global supply challenges have forced manufacturers to rethink their design systems. And now more than ever, we need to have extremely agile systems to manage the rates of change that we're having to constantly adapt to. One of the biggest changes over the past decade is purely the amount of data that we create and consume. And for designers and manufacturers, that presents some real challenges. And so being able to collaborate seamlessly is quite critical now in the process and production of new equipment, and with the design and production workflows that we're often challenged with. And this is really where Fusion 360 shines, with options to easily share files and communicate design developments without being connected to a physical server. It's sort of the new normal in that sense, that cloud storage, as you're probably all aware, most of us would have a Dropbox account, or maybe for businesses, certainly using Amazon servers and products like that to store their data. So being able to access that very quickly through the interface within the model is quite important. And so we're going to explore this a little this morning. I'll give you a bit of an introduction to the concept of how that all behaves. And like I said, our main focus today is going to be around surface and freeform modeling. And I'll be doing a live demonstration shortly just to give you a bit of a rundown on how those systems all work. But again, just a couple of other key aspects of Fusion 360. Some of you may have come across some of the other Autodesk 360 applications. You might have heard of BIM 360 or Drive 360. There's even an AutoCAD 360. And basically, most of these tools are cloud dependent. And what we mean by that is you need to be connected to the internet at all times to be accessing, for instance, your architectural data via the BIM 360 interface. Fusion is a little different to this, and I'll highlight this as we go through our demonstration in a moment, but Fusion can function in an offline mode, meaning that if you're working away from the office or you're in a remote location, you can still run your Fusion application in what we call offline mode. So what we can do in that space is save our files to our local drive, and quite a lot of people are concerned about having files saved up into a cloud space, obviously with some of the challenges with internet securities and things like that. But with Fusion, we can save our models back to a local drive if we would like to. So that is another option as well. But one of the big points is, as I mentioned earlier, we are creating an awful lot of data these days, and being able to collaborate and share that with the team via a cloud application may be just what your business needs. And so we're going to be talking this morning about some of those aspects of working with Fusion's fantastic little interface, which does many, many powerful things. Like I said, Fusion is sort of the new kid on the block. It's quite a new CAD application in that sense. One of the other great features is that it will function happily on a Mac. So if you're using a Macintosh computer, no problem at all. Fusion can function natively within the Mac or Windows environment. So that's quite a game changer as well. As we know, many people are choosing Mac machines, and certainly being able to run a CAD system like that natively on a Mac is quite a valuable part of the Fusion interface. As I mentioned before, it's not just a CAD system. It does include many other tools, including things like rendering, simulation, so we can simulate our machine design or our model as we create it. And that means that users can keep all their data in the one application. Fusion also has the option to create sheet metal flat patterns. So we can create a flat pattern of a sheet metal model part. We can also animate exploded assemblies. And one of the other very powerful tools is the built-in CAM system, which Fusion leverages to allow us to output and post code to a CNC machine. So we'll be spending a little bit of time and focusing on some areas of those aspects during today's live demonstration, which will start in a moment. So starting out, and today I guess to put the whole freeform modeling and surface modeling into perspective, basically Fusion has three separate modeling modes, if you like. First up, we've got the solids modeling mode, and many of you would be familiar with this, perhaps having used other CAD systems, or if you've dabbled around in Fusion. Creating solid shapes in Fusion is very, very easy, very quick, and we're able to create a solid shape that has mass and many other physical properties that we can use for doing dynamic simulation and stress analysis. So when we assign a material type, a solid shape has, for instance, the volume and mass of that particular component. Certainly mechanical engineers like the solid modeling mode because we get so many other properties with that, and we can assign a material to that and pick up from the physical properties and the center of gravity and many, many other aspects of our solid model. We won't be spending a huge amount of time here today. We have covered that in previous webinars, but our real focus today is going to be around surface mode. So this is the second of our 3 modes. Now, surface modeling has been around for many, many years. It was introduced in Fusion when it was first released. So surface modeling is it's been around for a long time. And basically with a surface, when we model something, we would generally represent, for instance, just the outer shape or perhaps aspects of a model that show the form of that particular shape. Surfaces in most CAD systems are 0 thickness in that sense. So it's almost like if you like to coin a term, it's almost like a cling wrap version of your model. It's just a surface overlay of your model. So surfaces don't have mass properties. And that's really probably the big difference of working with solids modeling, is when we're working in surfaces, we don't have mass for that particular part. We can calculate volumes, but generally we would use a surface modeling tool for slightly more complex shapes, say like a yacht hull maybe, or a car panel that has a very free-flowing and flexible shape, if you like. And we'll certainly explore this option as we go through our demonstration in a moment. And the third and final mode that we're going to be talking about is what we call our T-spline mode. So T-splines in Inventor, and often referred to as Nurbs Surfaces as well. So you may have come across that expression in the past. So basically, we don't access the splines area from a specific menu like we do with solids and surfaces. But as you can see here, we can access the spline mode by going into the create form aspect of Inventor. Of Fusion, and we'll be exploring that today. So Inventor does have the same tools, apologies for that, but we're certainly talking about Fusion today. So the Freeform tools inside of Fusion are different in the sense that it's more of an artistic feel, I suppose, in the sense that we can create a basic shape and then we can push and pull different parts of our shape to create a particular form that we might like to work with. So it's almost like modelling with a lump of plasticine or putty, if I can take you back to your childhood. When we're modelling with Freeform mode, which we'll explore in a moment, like I said, it's almost like a push-pull, sort of almost like squeezing putty or plasticine through your fingers. And it's quite, it's quite an interesting space. But like I said, it tends to lend itself a little bit more to the artistic side of model shape creation, in the sense that we're able to push and pull faces and change the way they physically react with others. And look, one of the key benefits with using this is that we can use all 3 of these modes within the same model. So we're not having to chop and change into different physical pieces of software. We can work with solids, we can work with surfaces, or we can work with the T-spline or form area of Fusion, all within the one model. So there's no need to switch out and change over to another piece of software to do this. Obviously, in the past, many softwares have been very, very good at doing surface modeling. You might have heard of Rhino CAD, which is another very, very powerful surface modeling tool. But within Fusion, we can do many, many things and create all sorts of different surfaces and forms, all within the one interface. And that's what we'll be working through with our demonstration shortly. So what I'd like to do is swing over and open Fusion and have a bit of a look at this. So with regard to Fusion, Fusion, like I said, is a very powerful and clever system that has many aspects to it. And what we'll be doing today is exploring some of those aspects. So first up, I just want to explain 1 or 2 things. Like I said, Fusion has a number of different interfaces, in the sense that up in the top left of our screen here, we've got the design interface. Now within the design interface, we're going to be using both our solids mode, our surface mode, and also our create form mode. So they're all within the design environment. And generally what we're going to be doing here is designing a part, maybe an assembly, maybe a sub-assembly within the design environment. We've also got a tool here for generative design, where Fusion looks at a model that we might have created and then optimizes it for retaining strength but reducing waste. So if you like, generative design does a computer-generated model of your, in the example here on the screen, you can see we've got an example of a little caster, and basically the support bracket for the axle on that caster has been run through a generative design process that reduces the amount of material needed to create the same strength within the part, but obviously making that part a whole lot lighter. We've got a very clever little interface for doing realistic renderings, where we can add lighting styles and shadowing and reflections, as you can see there. So that's another aspect of Fusion's interface. We've got an option to animate an assembly. So we can pull an assembly apart and save out a recording of that for maybe a service document, or perhaps to show how a user would assemble a particular part of a machine tool or whatever it might be that we might be modeling up in Inventor. We have simulation mode, where we can apply stress and simulate real-time studies on the loads that are created within a particular model. So that's another part of that. The manufacture mode takes us into the CAM space, where we can generate toolpath for a number of different machine tools. There's quite a list of post processors for different CNC machines, and we can effectively post out cutting data and toolpathing for particular CNC equipment. And finally, and this will be our last in our series of this particular parts of these webinars, is the drawing environment, where we can create 2D drawings ready to print or save to PDF to go out to our workshop that our users can then, our manufacturing people can create our componentry with. So like I said, today we'll be mainly staying in the design space, because what we want to look at is simply the solid modeling mode, surface modeling mode, and as I mentioned before, the form mode. So we'll be going through and just touching on some aspects of these particular parts of the Fusion interface today. As I mentioned, one big benefit with Fusion is its option to be connected to the cloud. So in actual fact, on the data panel, which I've got on the left of my screen here, is actually my cloud storage area. So you can see this is going to an F360 drive account, which is effectively like Dropbox, but it's built into the software. So effectively I can go in and look at a range of different projects that I might have here for a range of other users or whatever they might be. And effectively we can go through and open projects for any of those particular aspects of our Inventor session. So that's the data panel. Like I said, it's effectively where we save our files directly to the cloud, if that's how you choose to do that. As I mentioned, we can work in offline mode with Fusion 360. So up in the very top right, you've got a couple of little icons up here in the very top right. You'll notice we've got the option here where we're signed in to our 360 account. But under this, this little clock, the little clock icon here, you can see that I've got an option where it tells me that I'm working online presently. And if I was to toggle that to offline mode, my Fusion would quite happily keep working for, I think it's around 20 days without needing to be connected to the internet. And we can save files quite happily to our local C drive or a portable hard drive or wherever you'd like to save them to for future reference. So we can work in offline mode, and that's quite an important part of working with Fusion. So Fusion is actually a locally installed app that runs on your PC, and obviously that is how we work with Fusion in that sense. It's not a cloud-based app in that it is cloud optioned by having a storage space in the cloud, but also we can save files locally. Okay, so what I'd like to do today is, first up, we're just going to talk about some surface modelling options. And just to give you a bit of a rundown, just very quickly and briefly, in the solid side of Inventor, if we create a solid shape, and the way we do that is we start off with a sketch maybe, and I can draw a shape here on my screen with my line tool. So we could draw a shape and simply close that shape. And effectively, to turn that into a solid now, I can come back to my solid mode and select extrude. Fusion now allows me to create that solid shape to whatever depth I would like. So we can pop in a value here for whatever distance we'd like to extrude that. This little tool here, we're going to come across a little later on. Basically, with the arrow here, I can push and pull to say how deep I would like my solid, or how thick I would like my solid. And this little function here allows me to put taper on my solid. So again, some very nice little controls on our actual solid shape. Now, the really cool thing about this, like I said, when we're modeling up a solid shape in Fusion, it has mass. So I'm going to save this particular part, and I'm not too worried about what I called it, but effectively in here now, we can go into the properties of the part and have a look at a bunch of engineering data. So we can find the center of gravity. We can find quite a lot of information about the overall part. So by default, and I haven't assigned a specific material to this, but it still tells me that the mass of this part is 3,212 grams, so 3.212 kilograms, 213 kilograms. Here's the volume, etc., etc. So whenever we model a solid part, we end up with all of this information for that particular part. So that's what we would commonly call solids modeling. And we can model all sorts of different shapes with solids modeling. We can shell that solid out to within a, maybe a 2 or 3 mil wall thickness and make that a hollow solid. And obviously now it's basically like a little bucket shape. And yeah, as you can see there, we're able to use the shape there to create our particular process. So aspects of solid modeling are for things like placing holes. If I choose to place a hole in this face and tell my inventor that I want to place a hole through there, basically, as you can see, we can model that solid feature into the inventor space. Now, what I'd like to do next is just take you through some aspects of surface modeling. So I'm going to undo just a couple of steps here. Let me undo. So I'm going to undo back to my original sketch, okay? So I've just gone back now to my original sketch shape that I had here. And effectively, I can go into the surface mode and do a very similar thing by extruding a shape as a surface. And again, I can still add taper to that surface, okay? So this particular surface, which, and again, here we can add the depth value for that particular surface and pick OK. So this is a surface model, and as you can see here, it's a completely hollow model. As far as Fusion is concerned, these walls are actually 0 thickness, so there is no mass properties or anything to that particular model as such. So that's effectively a surface model. Now, within the surface environment, we can certainly do a number of different things. So like I said, we've just done a surface extrusion. We can do a revolved surface, a swept surface, and again, in the drop down here, we can have a lofted surface and a range of other options for creating various surface models. Now, with regard to the way we model a surface as such, is that we can pick up to model surfaces and work with those surfaces, with regard to working with that. So my apologies. So with the surface, like I said, I'm going to undo that extruded surface And I'm going to go back into my sketch now and right click and edit the sketch. And I can just pop a line in here as maybe a, so we can pop in a line which might be just like a revolved axis. So I'm going to finish my sketch. This time I'm going to pick a revolve, and we're going to revolve this surface model around this axis. Okay. So what Fusion will do at this point is, again, this is a completely hollow model, so it doesn't have any mass properties as such, but in here we've revolved now to create a surface model based around the that particular revolved function. Okay, so yeah, quite a powerful little tool there for creating whatever type of surface you would like. If I wanted to do a swept surface, maybe what I'll do is I'll go back here. I'm going to undo back out of my sketch and just create a very quick swept surface for you. And maybe a good example of a swept model might be the likes of a paperclip shape, for instance. So we can create a swept shape based on, and again, I'm not too worried about size in this particular instance. All we're going to do is just simply model up a profile and a path for our paperclip shape. As you can see here, I'm just sketching my path. Now I can see here that I haven't got a tangency, so I'm going to add a tangent constraint to those two features to make my shape work quite fine. Now when I'm doing a loft, what we need is, when I'm doing a sweep, we actually need to have two sketches. Okay, so I'm going to create a new sketch on my YZ plane. And all I'm going to do at this point is just simply draw a small circle, which is going to represent the cross section of my paperclip. Okay, and effectively for a swept surface, I simply pick the sweep command. You'll notice that it's waiting for me to pick a profile and a path. So this is my profile and this is my path. And I've now got a 3D representation of a swept surface. As you can see, it is a hollow tube, if you like. As I mentioned before, surfaces that we create in Fusion are zero thickness. They have no thickness to them at all. Now, I could do the same in my solid environment. And like I said, the benefit with doing this as a solid, and this is something that us engineers like, is the fact that we can do a swept solid and then work out what the mass or the weight of a particular shape is. So this particular item is a solid model as opposed to a surface. So you can see it's completely filled in here. And like I mentioned before, if we were to right click up here and go into the properties, we could see again the mass and volume and area of our paperclip. Okay, so that's a bit of a brief rundown on the difference between solid modeling and surface modeling. Like I said, I could go and model some surfaces in this same paperclip mode. We could go and create a range of different options and work on those particular aspects of modeling. Now, in the surface modeling mode, we've got a range of different tools here for creating a patch over a hole, for instance. Like I said, you've got your four key shapes here. So an extrude, a revolve, a sweep, and a loft. These would be fairly common shapes for anybody that's done 3D modeling before. We can do them as a surface or as a solid. Now, one thing that I'm just going to quickly do, I'm going to back up a little bit until back to here where we had our paperclip as a surface. Sorry, let's go to here. Let's do the surface again. And what I want to just show you is one other function in the sense that if I again create my sweep, and again, I'm going to pick this as the profile and this, let's do a sweep. Get the right function, would be smart. So yeah, we're going to create this as the profile and this is the path. So I've got a swept surface there, okay? Now, one of the really clever things that I can do with Fusion, and look, this would be the same for a lot of tools, and Inventor has this same functionality where we can use a thicken command to add material thickness to our model. So you can see in here, if I pop in that I want to make this into a hollow, but rather than being a 0 thickness item, I can thicken it to whatever thickness I would like, and either on the inside or the outside, so we can flip that particular functionality over. So you could drag that inwards as well, so we can tell Fusion how thick or how thin we'd like the wall of our particular tube, and we can click OK. So now I've got a solid model. So once I thicken something, it becomes a solid model based on the surface. Okay. Now, one other very important part of Fusion is the history tree down here. And for those of you that have been to our previous webinars on Fusion, down here we've got a number of options that are being shown as to how we created our solids model. Okay, so we started off with a sketch. We did our second sketch, then we created our sweep, and then we thickened the sweep to turn it into a solid. Okay, so the great thing about Fusion, like I said, we can work in solids mode, surface mode, and also freeform mode, all within the one interface. Okay, so we're not having to work with multiple solids and multiple different interfaces to create surface models and solids shapes. So look, the surface modeling part of Fusion, there's a lot of other options here for stitching surfaces together, for extending surfaces. We've got quite a few tools here for trimming surfaces. And again, for those of you that have tinkered around with different aspects of other CAD systems, you're probably aware that all the different tools that are available in surface modeling environment that allow us to work with many different types of surfaces, including ruled surfaces. Yeah, we can offset from a surface. So there's quite a range of different surface modeling tools that are available to us in our Fusion workspace. Okay, and just to point out as well, we do obviously run training courses on all these aspects of Fusion as well. So if you'd like some more information on that, I think we've got a course coming up at the end of April. We do a 3-day course where we touch on many of these topics. We start out by looking at solids modeling. We talk about creating assemblies and working right through to creating working drawings with parts lists and bill of materials and all those sorts of things in them in that particular training. So that's something you might want to look at via our website if you'd like to pursue further training in the Fusion space. Okay, so let's move on. Like I said, this we didn't plan to drill down too far into the surface modeling side of things, but what I want to do is for the next couple of minutes, just look at the third aspect of modeling in Fusion, and that's using the freeform option. So I'm going to leave my paperclip sitting over here, and we're going to go into this create form mode. Now, this is quite an interesting mode, and for people of an engineering nature probably look at this and sort of go, oh, that's more of an art tool than an engineering tool. And look, I would to some degree agree with that, but as time goes on and with the advent of 3D printing being quite available to us now, we can 3D print in a range of different materials, and we've discussed that in other webinars as well. So A2K do have a metal printer set up here in Adelaide that we use to print stainless steel and copper and a range of other materials. So that's another aspect of that. So creating free-form shapes can be quite beneficial in that sense. Now, the form mode, and incidentally, for those of you that have been using Fusion for some time, you might remember there used to be an interface called Sculpt. So back in Fusion 2014 or 13, they changed this over to become the form mode, which tends to be more of a direct or more of a correct way of how we model. So how do we use this form mode? Well, in Fusion, we've got the option to create a box, a surface, a cylinder, a quad ball, or a face. Now, these options are all quite interesting in the sense that when we go to create just a simple box, for instance, what Fusion's asking me to do is tell it where the center of the box is. So I'm just going to pick on screen, and then I'm going to draw a box. And look, we could make our box 100 millimeters in one direction, 75 millimeters in another direction. Okay, and basically I've got a 100 by 75 box on screen now. Now, what I wanted to do before I hit enter was, in actual fact, just jump back into here. I'll back out and do that again. Sorry, I jumped ahead a little bit quickly there. So we're going to do a box that's 75. Now, when we go to create this box, on the dialog here, so I've got 100 millimeters in length, I've got 75 millimeters in width. I can divide every face of that box up into a number of faces. So I can change the number of faces on each of these directions, if you like. So if I was to go 6 faces on the length, 4 faces on the width, and then I can specify the height here as 150 millimeters, okay? And as I said, we can then set however many faces we might like over that length. Now, this might all look a bit strange at this point, but once I pick OK to that, I've now got a multifaceted shape here that has many faces, also a number of edges and a number of vertices. So the vertices are obviously where these faces meet. And we can create any shape from this list here of shapes in this menu. Now, and quite simply, it's all done the same sort of way. So if I wanted a cylinder as opposed to a rectangle, I can simply pick here and say I want a cylinder 100 millimeters diameter. And I want my cylinder to be 50 millimeters long, and I'm going to have 4 faces and 8 faces like so. All right, so we've got a cylinder now that is created with that multifaceted mentality. And this is what we often refer to as a T-spline shape. Now, the real benefit of this is that we can use push and pull sort of functionality to drag faces and move elements on a particular face. And like I said, a lot of people look at this and go, it's more like an art form than an engineering tool. And I don't altogether disagree with that, in the sense that I can select a face and I get this rather complex looking glyph pop up on my screen that has a series of arrows, a series of rotational options. But effectively, if I click on the arrow here, so I can click on an arrow and drag that face, if I can pick the right arrow, all right, and drag that face to change the shape in any direction and push and pull that face. So we can just grab any of the arrows here and move that face to indicate another location. So you can see what's going on here. I'm dragging that face in a specific direction. And again, I'll grab this. We can also twist it by selecting an axis line there. So we've got quite a number of tools and options for creating a drag position. So if I wanted to drag down this way, we simply click that arrow and allow our model to move. So it's a very flexible and free-form method of modeling. Okay. Now we can do this by size. So if I wanted to drag this out by 20 millimeters, I can do so. So we can either select the face, we can also select an edge and do the same thing. So I can drag an edge out, and I can drag that edge in any distance. So we can pop a distance value in here and drag that to any particular location in our particular model. All right, so we can simply push and pull. Like I said, we can also rotate. So these round dial-shaped glyphs are intended to allow us to rotate an edge, for instance. Okay. Now, so there, in that instance, I selected an edge. If I was to come down here and select a vertex, I can do the same thing. So I can pull a vertex inside an edge like so. All right, and we can change the way that vertex behaves by just simply rotating or moving that vertex on our shape. Now that all looks very good and might be real fun if you want to generate a new wing mirror for your Ferrari or something like that. So look, being able to just simply drag, and I can do that on this particular shape as well. I can select a face, edit the form, and drag a face on my cylinder. So if you were getting very artistic and you wanted to create some sort of a fancy new vase or maybe a grab handle for a particular component, we could certainly do that also. So very flexible, and as per the definition there, it is a very free-form modelling type of process. Now, if I go up here and finish the form, what Fusion does, it converts these now into solid shapes. And I could quite happily now go up here and send these to a 3D printer and print that shape exactly as it is shown on my screen at this particular point. So we could quite happily go and print any of these shapes, and that's, I guess, the benefit of working with Freeform, is we're not constrained to any other aspect or part of our modelling in that sense. Now, there is a bunch of tools as well that we can use here. So I'm going to just jump back into the form mode again. This Fusion seems to have, I think, here. So we can jump back in and edit. Anyway, so yeah, effectively, if we were to go back to creating form and create a plane or a face here, either of these two options, and again, I simply select the face that I'd like this plane to be on, give it a size. So again, I type sizes for the value here, and again, the number of faces that I'd like to have in each direction. Okay. Now, one of the very clever tools with regard to this free-form modelling concept is that we can add symmetry between a multitude of faces as well. So in actual fact, if I wanted my model to be symmetrical, I've got this option here to select two faces, and then what Fusion does, everything that happens one side of this face will happen on the other side. So when we apply a mirror symmetry, if I was now to go and modify the form and select this face and drag it, you'll notice now I get the same option either side of the face. And look, let's face it, frequently in engineering, we are doing a lot of symmetrical things. So again, we can simply push and pull now to have that symmetry applied to two separate parts of our environment, if you like. So we can go in and change one of these faces and end up with a symmetry. So anything that's symmetrical, if we put a symmetry line down through the center of those faces, we get the behavior operating like this. So yeah, I think you'll agree it's quite an interesting part of the Fusion space is the free-form mode. Like I said, we do go through this in a little more detail in some of our training, and certainly working with some aspects of the way this free-form sort of system works is quite powerful. So effectively, the free-form part of Inventor is very much a flexible part of Fusion. And look, lots of different options in here for different ways of modifying the form. So you can see we've got many options here for different types of developments on our form. We can unweld edges, we can crease edges. There's a range of different tools here in the free form design side of Fusion that allow us to create a range of different options for working with the Freeform system. So look, I think you'll agree it's a very flexible type environment. It's designed to be a Freeform modelling situation where we can create any of these shapes and then effectively work with them by just simply push and pull different parts of your model. So I hope that's helpful in just giving you a brief overview of the different aspects of Fusion surface modelling. So we touched on solids modelling. The big difference with solids is that a solid model obviously has mass. Like I said, when I exit the form mode, Fusion automatically turns these forms into solids. So these would now have mass, and like I said, they are 3D printable or whatever you would like to do in that sense. So it is very much a functionality that works to our benefit in allowing us so much flexibility. So we talked about surface modelling. Again, a lot of different tools for creating different surface shapes and different functionality there, and for editing surfaces also. So we've got quite a range of different tools in that sense. And also, like I said, under the form creation tool here, we've got the option to push and pull faces, edges, or vertices to create more free flow shapes. So I hope that's answered some questions for everybody. Thanks again for joining us today. It's, I hope what we've covered today is of benefit, and that hopefully it answers some questions. Now, we do have a few minutes where we'll stay online for questions if anybody has queries or questions. So we'll stay online there. I see a question from David with regard to Fusion and Autodesk Vault. So there is some add-ins, David, for Vault and Fusion that work quite well together. There is a collaboration tool for working with Vault that you might like to explore. It's certainly a very powerful part of that. We can check files in and out like we would with Vault traditionally, but yeah, so lots of different options for that. Thanks for your question there, Reese, as well. Are there tools for making items watertight? Absolutely. So we can patch a surface, and basically the way Fusion works is if you've created a surface model and it has unclosed loops or non-closed surfaces, basically from there you would need to patch those up. So we can do what we call a boundary patch to patch over an area that might be causing a problem there, and the other options for doing that. Yeah. So once Fusion sees the model as watertight, it will solidify it. Okay. If it's got gaps in surfaces, then we need to investigate those gaps and work through that. So yes, we can, if you create a solid shape, and thanks Harold for your question there, with regard to if you create a solid shape, normally you would work the other way to what you're requesting there, in the sense that you would start off with a form and then it will convert to a solid, so then you can modify the form using the solids modeling tools. Generally it won't go the other way. So the lofted surface or the lofted form could be pushed and pulled. Once you've finished pushing and pulling, I would be working with that. So yeah, that's one other way of doing that. So Andrew's asked a question about translating into Revit. Thanks for that question, Andrew. At this point, I know there is some things in the pipeline for working more astutely with Revit. You might be familiar with the BIM translation from Inventor. So certainly we could model something in Fusion, take it into Inventor, and then convert it to an RFA file within Inventor, but not from Fusion as far as I'm aware at this point. So yeah, certainly working with Revit files at this point, but watch this space. I think you'll find there will be some interesting developments there as different disciplines work together as we go. Any other questions? I think that covers most of the questions there. So again, thanks for tuning in today. It's been good to have you along. If you'd like to see some of our other upcoming webinars, like I said, we do have one other in this particular series of webinars. We will be talking about working with drawings in a webinar in a couple of weeks' time. So tune in for that one as well if that's of interest to you. It'd be great to have you along again to look at perhaps the final aspect. Although we may look into sheet metal and some of the other functionalities within the Fusion interface. So thanks again for joining us. Andrew's just asked a question with regard to SolidWorks as well. So certainly bringing SolidWorks files into Fusion is an option, Andrew. We can do that. You may not get all of your feature history, but you'll certainly get some aspects of that. So Raman's asked a question about exporting a report from to Excel. Not specifically, although obviously with your parameters, Raman, you are using very similar to an Excel type system. But certainly if you were talking about taking a bill of materials or a parts list, there are functionalities for achieving that, I believe. So yep, that would be another option. Well, thanks again for tuning in, and look, it's been really good to have you all along. Thanks for joining, and all the very best. And like I said, we are running a Fusion training course in a couple of weeks towards the end of April. I think it's the 28th of April. So if you'd like to learn more about Fusion, please get in touch with our staff. We'd be more than happy to help you in your journey along the Fusion path.